Hi, this is the tutorial for Unit 3.2, conditional, or what we call if statements. So when we look at this unit, we're introducing a really big idea in computer science. The importance of these cannot be understated, because what if statements allow us to do is make a decision about if something is true or not true, and act on that statement. So if something is true, then the if statement body will execute, and if the statement is not true, then it won't execute. So the thing that we're testing all the time is what's here in the parentheses. It's what we call the test or the condition. And if it's like a mathematical statement that you could evaluate as true or false. So in this program, we're putting a couple of labels up at the top. That's this stuff right here. And then we're deciding, when we click the mouse, are we on the left side of the canvas where the x value is less than 200 or not? So here it's false. All the x values anywhere on this right side are more than 200. And as soon as we cross the line, now the x values are less than 200. So this test, this conditional statement, will be true on any part of the canvas to the left of this center line. And that means then, therefore, this line and all other lines that are indented below it will execute. So that's how this works in its most simple form. So let's continue. There's a checkpoint here. I believe it's just a question. I'll let you do that. Now it turns out that, like I said, you can have multiple lines in the body of the if statement. Just like we have a body of a function, that are all the lines that are indented below it, we also then have the body of an if statement. And if you have an if statement inside of a function definition, you just keep indenting, right? So in this conditional statement, it looks like there's going to be two lines of code that execute if the mouse is on the left side. So first we're going to draw a circle, and then at the exact same place, you can see it. We're using mouse X and mouse Y, which store the current mouse location. We're going to draw on top of that a star. So the star is going to be black, and it looks like the circle is going to be a nice light blue color. So let's run this and look at it. So it's the same program as before, but instead of doing one thing, just a circle, we're going to do two things, a star and a circle. So in the next section, we're mentioning that there are lines of code after an if statement, so that are not included in the conditional statement. And we know when that happens because the indentation stops. So this is pretty important. When I click the mouse in this program, on mouse press, right, we're going to make an immediate test. If we're on the left side of the canvas, we're going to draw a circle. Now, there's only one line of code, line 7, that's indented, so that is the only thing that happens. Please watch this. When you click the mouse, this test is conducted. If it's a false statement, this will not happen, and then we say execution resumes below that. So basically we skip all of the indented body of the if statement if this statement is false. Skip it. So if we skip line 7, then line 8 is the next line because it's not indented. So what we expect to happen in this program is if I click anywhere on the left, I'll get a circle. And then, even if this is a true statement, yes, this will happen, and then we go to the next line. So line 8 will execute every single time we click the mouse. But line 7 will execute only if we're on the left side. So, graphically speaking, we're always going to get a star no matter where we click. But we may get a circle behind that star or may not, depending on where we are. So if I'm clicking on the right side, this conditional statement is always false because the mouse is greater than 200. So we're just executing line 8. But on the right side, we're executing line 7 as part of if statement, and then we're also doing line 8 every single time because we always get stars. And of course, there's one more example. And once again, let's try to predict what's going to happen. So we have the same labels as before, and we also have something new. We have a new label that's called left counter. So the left counter refers to a label who has an initial value of 0. So this is a numeric label, not a string label. It's not a word, it's a number. And as you've seen in previous exercises, we can do things with this value here. And the way to access this number here is label dot value. So since this label is called left counter, then the access to this number right here is left counter dot value. All right, so when we click the mouse, again, if we're on the left side of the palette of the canvas, then we're going to execute these 2 lines of code. What are we going to do? We're going to drop a circle wherever we are on the left side, and apparently we're going to bump up the counter. So this line 10 is the same thing as saying left counter dot value is equal to left counter dot value plus 1. And this is just an abbreviation of that. And then after we've done that, we will always draw a star. So this looks really similar to the previous program, except we just have an additional line of code to bump up the label value. All right, let's go look at it. So we click on the right, we get a star. So this statement is false, so we don't do either of these 2 things. We don't draw a circle, and we don't bump up the counter. But as soon as we cross the line, we're going to draw a star. But before we do that, those 2 things have happened. So first we're going to draw a circle. The order here is just as it appears, top to bottom. If you click the mouse and we're on the left side, it does line 8, then it does line 9, and then execution resumes. It goes line 9 and 10, and then execution resumes at line 11. So, just as you would expect. The point is here that we're just adding layers of complexity to this, but it's all the same basic idea. Well, so far we've been using the simple test if one value is greater than another or less than another, but there are a variety of different conditional tests that we can make, and you're familiar with these just from algebra. So we can test if a number is less than or equal, if a number is greater than another or greater than or equal, but there's 2 here that are pretty new to you because I doubt you've ever used these before. We can check to see if 2 numbers are the same or if 2 numbers are not the same. All right, there's something a little slippery going on, so I'm going to switch over to a sandbox and open up a new file and just show you a couple things here. So to demonstrate this, I'm just using the Python editor and I'm creating a little program. It's not a graphical program, but line 6 is the only executable line. Everything else is comments. And all we did was we say, I'm creating a new variable here, x, and I'm assigning it a value of 4. So just like in algebra, x equals 4. So the other thing we can do now is just to see how Python can display a value. We can use a simple print command, and I can print the string the value of x is, and then we can actually print the value of x. So this strx just enables us to print a numeric value as a string. It converts the number 4 into the string 4. So if I run this, what we're going to do is look down here for the output. All right, the output will not be in the canvas because this is not, we're not running the graphics library here. So it prints, the result of the print statement appears down here. All right, now this is where I need you to watch really carefully. This would appear to be a valid test that says if x has the value 4, then we're going to do something, right? The problem is, look at line 6. In this statement, we're using the equal sign to mean that we're assigning the value of x to be equal to 4. And the same thing is happening here. So in this case, we're not trying to set x equal to 4. It already is 4. What we mean to do is ask the question, does x equal 4? So the idea here is this statement has to be a question, and the question of equality is not a single equal sign, but it's a double equal. So the way that you would read line 12 would be more like if the current value of x is 4. So the single equals is an assignment, double equals is the question. So if we run this, we expect this to be a true statement, and then we'll print that, right? So let's run this guy, and there it is. And it turns out that this is a very common error. So when you're using a conditional statement, an if statement, and you want to test if two values are the same, make sure and use double equals. And the opposite of that, either they're equal or they're not equal, to say that two things are, or ask if they're not equal is like that. All right, so we've got all of these available tests to us to use. So in this example here, when we click the mouse, we're going to do these things. We're going to draw a circle, draw a star, and we're going to bump up the counter value because it started, remember, at 0 here. So every time you click the mouse, this is going to go from 0 to 1, 0 to 2, and so on because of this statement. And finally, we're going to ask the question, hey, if the counter value ever reaches 5, if it's 5, exactly 5, then we're going to turn that number to green. The background of the app. So the whole screen is going to go green. That's what I expect to happen. And there's a big hint here. And they're just basically reminding you of what I just said. People make this mistake all the time. And when you do, you're going to get an error. I'll show you what that is. But let's run this program and just kind of verify. So right now, 1, 2, 3, there's our star and circle. And as soon as I click 5, the app.background went to green. So we've got a couple checkpoints we can run through right now. Checkpoint 4 is the cookie clicker. So first, always read through these because these things are going to give you hints on what you should be looking for in terms of how this program should behave. So I'm just going to be clicking on anywhere on the canvas. Doesn't matter whether I'm clicking on the cookie. Oh, wait a minute. Okay, so I'm still clicking and it went from 0 to 3, but no more. Let's try this again. So click, mouse click, mouse click, mouse click. All right, so it looks like our mouse press is going to always bump up this number by 1 if this value is less than 3. Because if it was 2, it becomes a 3. If it's already a 3, it will not become a 4. So I think we have a plan for this program right now. Every time we press the mouse, we're going to bump up the counter value by 1. Now, this is not the final code, but let's just see how it looks here. But that's the basic action of this program is when we run it, every time we click, we're just bumping that variable up. But if we want it to stop at 3, then we need a little bit more code here. Because what I need to do now is wrap this thing in an if statement. And what's in the parentheses here is the test, right? And remember, we have to have a colon at the end. And most importantly, what used to be our code for our definition of the function now is part of the if statement, so it needs to be indented. So the indents here in Python will kill you because it's very sensitive to that. So now we've packaged our cookie counter in an if statement so it only executes if the current value is less than 3. So 0 becomes 1. 1 is less than 3, so it'll bump up. 2 is less than 3. The test passes, so we'll bump it up. And now, the next time through this loop, or next time I press the mouse, the test will fail, and the cookie counter will not get bumped. And in this last checkpoint, there's a hint there that basically says when you click the mouse, the number will only get incremented if the y value is bigger than the x value, which is anywhere in this region. So here's the code that matches. If the y value is less than the x value, we're going to bump it up. And I just have a comment here that says you could also write it the other way and test if the mouse x is less than or equal.